Okay, so in the slides and in the presentation, we basically covered everything, and I was even talking about the linear regression a little bit, but right now I will just go through it again, and then more importantly, I will go through the programming part with you, and yeah, just start with all the small start with just using the simple codes, and then just get on from there to what we want to do. I would like to show it visually. That means kind of illustrate what the whole task is about first in this on this small example. So we have a plot with just a bunch of points, and the points here, all of these are some records of people from some. I mean, it's some synthetic data set, so this is just some random data that I found online, and it can be imagined. It doesn't have to be really real, but it's a plot of weights and heights of humans. So each one of these plots corresponds to a person. So this is a dot which corresponds to someone who weighs something like 70 something kilos, and he is 1, 7, and 5 or something as height. And so I mean, these data and what we label these two lines, the x and y, this can be anything, right? So in the example of the collab, there is also another data set that is some diabetes measurements, and then you have some on the x-axis. You have something like BMI. I don't remember what it is called. It's some index of weight and stuff. And on the y-axis, you have some sort of probability of the disease getting worse. And honestly, we are looking at graphs and plots a lot these days as well. So this data can be basically any one of those. And so we have talked a little bit in the presentation or in the lecture part about having a model. And what model is, it is a sort of like a black box, even though that metaphor works until some degree, but then breaks. But still, let's just still use it. It is a black box that we sort of want to fit somehow on the training data, and then in the end have this model, and then be able to use it for something else. So the simplest model will be the line, and let's draw a line. Okay, let's make it red. What does it kind of? What is the? What makes this line to be a good fit for this data versus a bad fit? So this is very easy intuitively, right? If you have these plots, dots somewhere on the paper, it's really easy to just go, oh yeah, sure. I mean, I will just put it here. Oh yeah, maybe a little bit here. So yeah, basically, so just that this line corresponds to the data. In order to start kind of describing this mathematically, and we need to do that in order to have a model which can be kind of figured out automatically, we need to first start with the formula for a line. So I think this is something like a high school curriculum stuff. So sorry if it's too easy, but let's go through this. So what does this formula mean? It means that this line, this red line, is given by two parameters, a and b, and then whatever. So yeah, without still explaining what the a and b is. So let's say that this is the line and that a and b are some numbers. So let's say I will completely just randomly put some numbers here, and this is, I don't know, 155, something like this, right? So these are some numbers, which can be, I think they are not correct actually. This one is definitely not correct. Doesn't matter really. So this is a formula which will define where the line lies in the space. So for what this means is that if we ask this formula, give it any number here as an x, so sort of let's try on 50, and then evaluate this formula, we will get an y value, which will arrive at we will get a value which is here. Oh no, it's bending. Jesus. Okay, here. And then if we continue from there, I mean, this value should give us something like this. So somewhere around 160. this is clearly wrong. I have said some like this A and this B is something that we don't know yet because we just draw it on the board sort of intuitively. We didn't arrive to it with any analysis yet. So this is a way how to get this 1 point, and the way how to kind of get all the possible points in on the line is just trying basically all the possible values for y, for x, and then getting all the values for y. So yeah, we start at 50, then we can try at, I don't know, here, and then we will get this value, etc., etc., and we will get just bunch of points like on this line. We will be drawing the line point by point, right? So yeah, this is simple. Still. Okay, so maybe let's talk about these two parameters. What is A and what is B? So if I have a line like this, if I'm moving it up and down, that corresponds to changing the parameter B, because this is it's a so-called intercept. It will kind of influence how where the line is positioned in the space, going up and down on the y-axis. The A parameter is something which kind of corresponds to the slope. So now it's turning around this point, which is wrong actually. It should be turning somewhere around this. And the slope influences how tilted it will be. So somewhere around, I guess. So actually, these numbers are, we have different number, like different change of step in y and x. So I don't know which will be the 1-to-1 ratio, but usually when we have 1-to-1 ratio, it's if we grow by 10, then this will grow by 10 again, and that means that A is 1. If the A is much higher, then it will basically go up like this, and then if it's lower, it will go like this, right? Okay, so this is simple. And why did we even start formalizing this? Because it's not really that complicated. Well, we can use this formula as a starting point and then sort of start calculating errors. And errors are a way how to mathematically say if the line that we have placed here is positioned in a way that is nice and kind of fits the data, or if it's somewhere bad. So, like, very intuitively, this is a bad curve. Also, this is a bad curve. Also, this is probably quite bad. And so what it means to be bad means that the data distribution, all of these points, don't really lie on the line. So we really kind of want to place it somewhere so that it follows these. And yeah, so just so you note, this is working with 2 dimensions. We have 2 parameters, or like, yeah, two dimensions. One is height, one is weight. And it's super easy on this because we can just draw it on the board. But it becomes more and more complicated, and even more and more complicated to think about when it goes into more dimensions. So imagine that you don't have these as 2D points, but 3D points, and you are not putting in like a line, but a plane. And you can go even beyond, and you can have points which are many-dimensional, and then you are placing in some hyperplanes which are splitting the space into parts. So yeah, we are still here with 2D then. Okay, so in order to describe what it means to be good or bad, we can use these metrics of distances, because like if we place this line somewhere in the middle of all the points, then all of these distances are quite small, and basically that's the metric, that's the guidance that we can use to place the line or to automatically arrive at the best position of the line. So how to create the distances? I mean, there are so many ways to do this. You can have a metric which is looking at these distances, not squibbly like this, but whatever. But this is mathematically slightly more complicated to calculate, so we will not do that. We can look at these distances, because why not? This is also proximity to line in some sense, right? But in this demo, we will be looking at these distances. So the proximity of the point to the line in the y-axis. So yeah, all of them seem to be roughly good. So what does this mean mathematically? I guess we already do have this point, because this is the point, I guess, underscore its coordinate y, and then we can get this y by asking, by basically placing this this point x, getting this x into this formula here, calculating whatever is returned with the y, and that will be the value which goes here, right? So this will be the line y. Okay, horrible scribble, I will erase it. So we will get the line y. Cool. So yeah, these are the two values. We can then start measuring distances, which means basically having this value minus this value, which will give us this amount of space, just the distance. Or as we were mentioning, or like as we were discussing just before this call, we can also start, instead of just dealing with this distance as this line, let's make it also red, we can start considering the square of this distance. So that would be okay, something like this. So the area of this square. And so what that means is that this point will contribute with this sized square to this to the kind of accumulated error that we are that we have. And I will not do it for all of these, but basically you can imagine that there are these squares that are sort of slowly accumulating the error. Yeah, this happens for all of those squares. And so what we want to do really is to place the line in a way that the sum of all of these squares will be the smallest, or the average sum. It doesn't matter, because if the number is the same, if we are minimizing this number. So if we multiply it by something at the start, it doesn't really matter. So yeah, everyone gets this kind of visual representation of this. I think it's too simple, right? I didn't want to start with like too basic thing, but also didn't really want to intimidate you with something complicated. But yeah, is this good? I'm seeing some
faces. Yeah, that all makes sense.
Okay. Cool. Right. So, I mean, this is it basically. It now just we just have to convert this into code. And so, just to start this, let's do this maybe together, one by kind of. In your cases, maybe do that on side screens. So on one you can stream this video, and on the second one you can work with the collab. So I would like you to open. Well, actually, yeah. Let's start with this. I would like you to open our Git. So I will paste this link to the chat. Okay. Okay. So if you open this, we have our week 1, and then I updated this this demo just an hour ago. So please update it if you have already downloaded this. You can open it. Then, as was in the lecture, just copy this link. And then go to a collab.research.google.com. Right? I will maybe again like copy and paste this one here, because rewriting everything from the screen can be complicated. And then let's go there, and we will now kind of make a copy of this document that we see here on Collab. And Collab is I guess you already know how to use it. Some of you, most of you probably. It's an online Python which is running somewhere on virtual machines by Google, and the advantage is that it can access some GPUs, and then later can use quite some like we can run some complicated tasks there, and it's also relatively simple to set up. in terms of like installing libraries. Yeah. Okay, so in here, click on the GitHub page or like tab or something. Paste in this this IPython notebook link. Sorry. And then importantly, don't click new notebook because it will just create new thing which is empty. But click on the search, and it will create a copy of this IPython notebook in your own Git, in your own Google Drives. Okay. So this is what we will be using. So it is an environment where we can just start writing a Python code. We have to trust me that it's all okay. We will start by importing just a bunch of libraries that we will be using. So Python is quite nice language because there are quite a lot of community-made libraries, and so we don't have to write everything from the ground. So this includes also Keras, for example, which is a library that we will be working from with next week. So that is a deep learning library. So it will make everything much easier than just having to write all of those math formulas ourselves. Cool. And so here, this is just loading of the dataset. So we have 10 points. Well, this is sort of corresponding to these. So we will have these 10 points. Then there is some kind of just changing this from a regular list into a NumPy list, which doesn't really matter. It's just converting from list to list, so it doesn't matter. But this allows us to then use shape and to just handle the data quite nicely. So yeah, let's do this. We have loaded 10 of these points, and then we can start plotting them. And so here, this is the code as well. We are using the matplot library, matplotlib library, and the command plt, which is something that we have imported here. .scatter will allow us to just put bunch of points here. So if we, instead of scatter, if we write plot here, it will do the same thing, the same data basically, but just connect it with lines. But yeah, this is not what we want. We want to actually show it as points. Okay, nice. And so there is actually all the code here, but I will try to start writing it here again, sort of, just to so you can follow one by one what is happening in the code. I guess sometimes it's tricky when you have just a bunch of already written code. You just click run and then everything works, and so it's a little bit, you can get quite easily lost into in the sense that you don't know what happened or what is actually happening inside the code. So yeah, so let's plot a line. What is a line? Well, a line is basically this, using 2 parameters, and then because it's a programming language, we already do have to give it some initial values, and we don't know what the x would be, so let's say that x would be also at 0, or yeah, and then let's print whatever this result will be. And so yeah, sorry for starting simple again. So this will give us a point on the line at 0 and 1 coordinates. Cool. I mean, this already is a line somewhere, but we would like to have something that we can plot. I guess the best way would be, as I was kind of explaining here, the line is basically just composed of a bunch of points that are on this line. So we can just sample all of these points and then connect them using the plt.plot, and that will create a line there as well. So let's make this a function of x, let's say. If we want to access these 2 parameters that we set outside, we will have to do this trick, and this will just kind of expose these variables to be inside of it, and then let's return return the y value. And so in that case, I can also do this, and it will be the same thing as before. Cool. And so this allows us to kind of go point by point and maybe have some samples, and then use those samples to draw the line. So I will say line x samples, and this will be just bunch of points. Well, I could continue writing like this, or I could just write it as a range from 0 to 100. Then let's convert this to a list. I think this might be it. And then len y points will be just we can start with this being empty, and then for all of those points we can just calculate whatever the y value would be, and then add this. So y is this, and then right. Stop me whenever it's too simple, or no one is stopping me, so it's probably really easy still. Again, sorry for that. It will get more hardcore soon in later classes, but yeah, I still wanted to start with something simple. So yeah, let's say that this is from 0 to 10. So cool. These values are the numbers on the line, basically points on the line, and so we can show this as x and y. Let's have it red, and let's actually plot it and not scatter it. So not show it as points, but show it as the line. Ta-da! We have a line. Okay, so let's just combine this with what we had before. So now it should be showing all the points from before and also the line. Okay, and let's trig this into just automatically adapting to whatever we have. So basically just range from the smallest number of x coordinates, so from here, to the largest number in the x coordinates, so here, and it will just make the line so sort of like fit with the data, in the sense that like it will just copy the x coordinate. So this is good already, actually, and we can now start experimenting with these two parameters. Yeah, this is useless. So as I was saying, a, that's the slope. So if we change it to something higher, it will turn around 0 and kind of go up into much higher slope. Or if we go into something below 0, below 1, it will be more flat. So I think that like the 1 looked nice. So let's keep it at that. And b is the parameter which will push this up. And basically that's what we need, right? And so if we can see this is 45 or something, we want to get to 145. So let's try adding 100 to it. Okay, and so this is some attempt at a line. If I try changing this to slightly lower number, it will be another attempt. And still we basically don't know how well we are doing. We know by checking this manually, just like looking at it. Yeah, this looks nice, right? But we don't know if this is the optimal one. Right. So how to... Yeah, for this we need to go with... start counting the error. And as we were saying, the error is the distance from here to here. So let's write a function basically, which will give us error between point and line. Let's have something like this. Point y. I mean, if you have looked at the final code, there is something like this already. But yeah, I'm rewriting it slightly here. Maybe to have it slightly more clear what it's doing. Okay, and so from the x point, so this coordinate, we can kind of actually get whatever the y coordinate of the line is. So if we similarly like here, line x, if instead of line x we will ask this from the line, it will give us the line y, and then we have line y and point y. So we can say that the distance, so the thing that we had here, this distance, is the point y minus line y. Oh yeah, and then, I mean, we would like to return something, and as we were saying before, we actually want to return the square of the distance. So let's say that this is the square of the distance. Cool. We have everything prepared to get the errors, but we still don't have that in the code. We are not checking one by one for all the points. So let's go for point. Well, let's say for index in range all the way up to all the points in dataset. Well, yeah, okay, let's use the x base. Well, no, let's actually use the dataset, because yeah, this can be changed to whatever other dataset we have. Okay, then point x is from dataset on this index. Point y coordinate will be that one. Let's just test it if I made some mistakes or something. Okay, cool. So looks good. And then we can count the error for whatever the A and B that we set here. So let's still copy these two here, just to kind of be able to change them, and then say error is, yeah, basically this. Error is counting from whatever the line, these two kind of global parameters will give the line, and then for these two entry points from the point E, Y, and X and Y. Okay. Nice. And yeah, there are a bunch of numbers, and we can kind of accumulated error, too many errors. We can just sum this together, and this basically gives us a metric or a measurement of how bad we are doing. So we can explain something like line given by, well, AB gives us error this. Right, so this is a number. We have no idea what this number is in relation with other numbers, so let's try this with some, like, I mean, we knew that something like 1 was doing worse, so let's just try it. Yeah, this is getting us much higher error. So let's just go back in this then. So kind of, I guess this is really still simple. Bringing this into a more into what we will be doing with actual models, we will have some parameters inside even more complicated models than a line, which we will be changing somehow, not manually, I promise. And then we will have some sort of error metric, so something like this, some distance between the data points that we have and whatever now we are trying as a model, and this will give us an error. And so this error will always be something like this, basically. We can then try it on some data and then see how well it's doing on this data. And if you remember from the slides, there was a distinction between training data and testing data. So you can sort of train it on one set of data and then test it on a different set, which means that you can kind of test how well it is generalizing to something else than what you trained it on. And then there is, yeah, we will talk about all of this later. Okay, so back to our line. Doing this manually is really boring, so you could basically brute force it. In the code I did brute force this, so you can go for A in range, I don't know, alright, but you cannot write floats here, I think, so you can just go from, like, yeah, I don't know, -1000 to 1000, and let's say this is just integers, and then for B in range -1000 to 1000 again, and then let's say that the real numbers will be just divided by 10 or something, because we want to try that, and then we can kind of place all of this into a function. So let's have a function called evaluate a and b. Let's call this like that we are trying these two. Now I will just rewrite whatever these two are into the global variable, and then I think this should work, and then we can just return this error. So I can now try with a and b. I think this should give us the same thing. Yep, it does. And so instead of this, we could just try these two, right? So we can say, yeah, basically we can just copy this same thing. Well, and we will go slowly mad because it will A be slow, and oh wait, shit, I also didn't divide these by 10. So this is not the way to go. However, it is a brute force approach, and it is a valid approach, I guess. But it's slow and also not optimal by far, because we can miss one of these numbers, right? But yeah, we are spending a lot of time on values which are getting really bad errors as well. So this is not the way, clearly. But just I wanted to show it. I think it will maybe crash even. Please stop. Okay, it will not. So the lesson here is brute force is usually bad. Okay, so I will skip a little bit forward. There are some methods in the sklearn, so something that we have been importing here, namely the linear model, and then namely this error function. And basically this error function is the same thing that we were writing here as a error between point and line, I guess. Well, I guess as this sort of. And then the line function is also basically the same thing that we have been doing with the line. But the terminology there and like the way how you actually call this function is a little bit different. So I will just cheat a little bit and just copy paste this piece of code to have all of this hard work done automatically. So this is not such a hard problem. There is an optimal solution, so you can actually arrive to a mathematical formula that you can then check, like derive and get the minimal value for this, minimize something, and so it's relatively easy. But it's also limited, right? It's just fitting a line. So let's say, I think we need to just change a little bit some of these. Well, that does at x, y. I think this maybe should work. So it will again give us a and b. So let's see sklearn a, b. Let's try it. Okay, yep. So, right, I think we can now try plotting these line samples as red, and then also generate new samples which will be created just from these parameters from sklearn best a and b. So to do that, we will just say a is here, b is here, and so what happens, we are overwriting the global parameter a and b, so then the function called line will actually access these two values instead. So it's not the prettiest code by far, but it really doesn't matter, does it? So let's now do this for these samples, and let's call them sk, because they're derived, or maybe just automatically, or no, optimally, right? Yep. Naming your parameters is important. I guess not really now, but yeah. Yeah, one is yellow, let's have this one orange. And then let's see how these plots go. Okay, they break somewhere. Oh yeah, because I renamed one of them, but not the other one. I should have built this into a function. Anyway, Okay, so this looks good. The one that was it looks like it's doing the same thing basically. It's also plotting a line. This time it's an orange line, and this time it's a line which has a different error. So we can also compare these two. So we have not divided this by some numbers, right? So I think they divided by n, so the amount of items in the dataset. So the number of mean squared error will be different, I think, but we will still see two numbers, and one of them will be worse than the other one. Right, so line given by these two manual parameters gives us this error, and then line given by this parameter gives us this error. What's happening? Okay, yeah. So our manually found line has this error, whereas the optimal line that was found by this method has this error, which is, yeah, this is how it works. Okay, so this is basically the end of this example code. It was, I guess, really simple. So yeah, I wanted to start somewhere where it will not get too confusing. But we can kind of bring some concepts from here and then use them later as well. So, for example, all of this can be called training. So we have trained the model, and we have trained the model with these two lines. And the model is this same formula that we have had before, right? So this. So in A and B, we now have these two, scalar and best. And let's say that we want to check x to be what happens with people who have, like, I don't know, I don't even who are at 100 of, what was it? Yeah, weight of 100. How tall should they be? I mean, this is synthetic material, right? So just like let's carry on with this. And so then model output y will be this number. And so we can also say that model is predicting for x equals whatever the check x is to arrive at y equals this number. And so, well, what it does, it just goes around to 100 and then checks what the intersection with, I mean, what is the number on the line. So, yeah, they should be really tall or something. Well, this doesn't work because it doesn't work with this amount of data, because we have been fitting into something super simple, right? So it's not the best model, but it's an illustration of the concept. Well, so what we can do then with this trained model is to actually use it, test it, which is this part. Yep. So right now you saw all the sort of intestines of what was happening. So you saw all of this dirty code that I was writing here, and then you could see how I'm getting the error, how I'm trying to get the best error, sort of, that maybe the brute force approach actually is sometimes done, but maybe it's not the fastest one. And yeah, you could also see how I'm calculating the different errors. So in the later models, we will not go through all of these steps. I think you will be glad to learn, because otherwise we will spend hours and hours on these simple examples. But we will still work with the same concept. So we will work with error, try to minimize it somehow. We will work with different models, and we will check kind of different setups of parameters for different models and try to find the best set of parameters which will get the best error for this model. Right. So this is kind of over for the practical section. Any questions? Any confusion? Any remarks? Anyone still alive?
I was wondering if it's possible for you to send that script later after the class.
Yes. So this filled out version. Yeah, I will definitely. So the version with the final code, which more or less followed the same thing. I named some things differently, I guess, but it sort of follows the same thing and is maybe also more commented. Is already there, and you can download it now. But I will also kind of update it with this field in the starter code.
I've got a quick question.
Yep.
If I try and call the min or max function on a NumPy array,
Yeah.
I get an error saying NumPy float64 object cannot be interpreted as an integer.
Right.
Is that a common thing? Does NumPy by default create float-based arrays? Do you know?
I think so. Maybe they probably uplifted it to the but actually, like I can. So right now, height here is an array, which is NumPy array. I think what would also work is np or numpy.min, I think, and in that case you can get this. So this one should work with any types.
Okay, cool.
Right.
I'll try that.
Maybe in the S array, if you here put something like, I don't remember yet, the D type equals, and then I don't remember these at all, but it will be something like, I guess that then the first one should fail. Well, it's still not failing. I don't know. Your computer is haunted.
Yeah.
That's the.
Yeah, alright.
No, but try using
I'll have it.
np.min, and this will. I think this will work. Okay. Okay. So if there are no other questions with the practical section, I will sort of close it and then repeat the. Repeat the ending of the class. So I will update these with the newest version, and then we can. Yeah, look forward. I will start preparing, I guess. Look forward to the next class, which will be on the basic building blocks of actual deep learning models. So not just a line, but having something more complicated, which is still built from some basic parts, but then makes all of those examples that you saw actually work. So that will be the contents of the next lesson. And then in the practical section, we will be working with Keras. So we will be sort of doing what we studied around about here in the lesson part in Keras, so actually writing it in code. Okay, so for those of you who have seen the video till the end, probably maybe most, you already know that there will be a homework. I'm sorry about this. So this one is really easy. So the weekly quiz, I think the purpose of it is just to, I guess, have some measure of attendance, I guess. I think it maybe substitutes attendance. So this is on our Moodle. At the end of the page there is week 1 quiz. I opened it and I also added some like the description there. So basically it's saying write a little bit about yourself and so what I want from you here, it doesn't have to be super complicated. It should be somehow explaining where you are coming from, and if you have some ideas of how you could connect that with some machine learning techniques. I guess, so why I'm asking it, I would like to know who you are as well, rather than just hearing your voices. But I also would like to kind of maybe change the classes in a way that they accommodate for whatever like the topic that is most useful for you would be. Right. So if you have some examples of projects, I mean guys, whatever, you can also upload it here, but that's not necessary. You can also write what you expect from this class. Yeah, because that will also help me kind of stare around the topics and the lessons for next week's actually. Okay. And so the second homework is reading this paper. So if you look at this is a web page that we will get slightly more accustomed to. It's a page called archive.org, and they store a lot of academic papers. So this is a link directly for the paper, but you can also get there by going on our GitHub, and there is a link to the reading, so the Khan Creative Adversarial Network. Yep. So this is a a paper written by an academic, which is basically a scientist who is trying to talk about generative adversarial networks and how they can or maybe are not on default creating art. And so they are trying to basically define what is and what is not art, which is silly a little bit, I guess, but happens again and again, I guess. And so yeah, it's an interesting read. The system generates art by looking at art and learning about style, and becomes creative by increasing the arousal potential of the generated art by deviating from the learned styles. Yeah, so what I want from you is just to read some parts of this. It's quite a long paper. It has 22 pages, so I chose some, just some parts. And also you will be reading about something that you don't know the complete technical background about, so I skipped like the technical details part, basically. I would like you to read up until this moment, so the first intro and then background, just to kind of read what how they are talking about this this whole topic. So while they are academics, they are also somewhere on the edge of arts and AI or machine learning. So it's not completely not complete mathematical gibberish. It's also actually trying to bridge these two domains. And so when you are done with reading the intro section and the methodology, just have a short skim through whatever their results were. So somewhere around here it starts, and so how they were validating it, and maybe actually visually also check what they are doing. And yeah, I would like to know your opinions on what you have read. If you think that their approaches were actually correct, if you believe them as fellow artists, that this description of an artwork is actually something that could work for you. Yeah, all of that. We will talk about this paper in the beginning of the next class, or maybe in the beginning of our kind of live session of the class. So you don't have to write anything per se for this paper. You just need to read it and maybe make some short notes, or maybe highlight some sections of the paper. Yeah. Later in the class, we will also read some other papers, and I will have some questions for you, kind of testing if you were able to grasp what they are talking about. This one is really, it's an introductory class, so it's just more, I will not test this per se. Okay. I think this is all then, so I will leave it at this.